Okay. Try your best and solve these 17. One. Let u equal 4x squared minus 12x. Then du equals 8x minus 12 dx. So the integral becomes u to the 4 du, the integral of u to the 4 du, which is 1/5 of u to the 5 plus c, which is, in the original wording of the question, 1/5 of 4x squared minus 12x all to the 5 plus c. Okay. Correct. Let u equal 2 plus 4t to the negative 3. Then du equals negative 12t to the negative 4 dt. So 3t to the negative 4 dt multiplied the right hand side by negative 1/4. Must do the same for the left hand side. Just there like that. Now, the original integral becomes negative 1/4 of u to the negative 7 du. And how to do this? Times by the power and then take one off. So 7/4 of u to the negative 8 plus c, which is 7/4 of 2 plus 4t to the negative 3, all of that to the negative 8, all of that plus c. Okay. Okay, so they did what I did. Oh, darn it. It's... I always do these... When I switch from differentiation to integration, like I'm starting to muddle them up. So I need to get my head straight. Add 1 to the power and divide by. Okay. 1 over 24 u to the negative 6 plus c. And that is 1 over 24, open brackets. Replace it with u. So 2 plus 4t to the negative 3. All of that to the negative 6. All of that plus c. Okay, that's good. Problem 3. We'll use u substitution. We'll let u equal 4w squared minus 6w plus 7. We'll take differentials. So du equals 8w minus 6 dw. That's true. W dw, just like that. So the original integral becomes negative a half u to the 10 du plus 1 and divide by that. So negative 1 over 22 u to the 11 plus c, which is negative 1 over 22, open brackets, 4w squared, take 6w plus 7, all to the 11 plus c. And check. That's correct. Next up, problem 4. We'll let u equals z squared take 8z. Then du equals 2z minus 8. So du equals 2 of z minus 4 oh, beg your pardon, that should all be dz. dz right there. And then we need to think, how do we turn that 2 into a 5? We multiply both sides by 2.5. All right, or 5/2 if you like. So the original integral becomes 5/2 times the cube root of u du. Then computing this is u to the third. So that will become u to the 4/3, but then divide through and 3/4 of u to the 4/3 and times that. So 15/8. Like that. And then the original u was z squared minus 8z all to the 4/3 plus c. That's correct. Problem 5. Let u equal 2 plus 6x cubed. Then du equals 18x squared dx. Five du equals 90x squared dx. So that at the front and that at the back I can replace with 5 du, and that in the middle I can replace with sine of u. So the original integral becomes 5 times sine of u du minus 5 cosine of u plus c, which in the original wording is minus 5 times the cosine of 2 plus 6x cubed plus c. That's correct. And the next few. Okay. d by dx of sec x is sec x tan x. So the integral of sec x tan x is sec x. So we can just simply let u equal 1 minus z. Then du equals minus 1 dz. Therefore, the original integral becomes the integral of secant of u times the tangent of u, and then dz gets replaced with negative du. So it'll be there like that. And we know that the integral of sec u tan u is sec u just there like that, and then replacing the original, we obtain that. Yep, that's right. We'll let u equal t squared plus 6t to the negative 1. Then du equals 2t minus 6t to the minus 2 dt and this needs to be multiplied by negative 5 over 2. Just there like that. So I can replace the start and the end with negative 5 over 2 du. Now the original integral becomes negative 5 over 2 in the front, cosine of u du. What's the integral of cosine of x? Sine. And that becomes minus 5 over 2 sine of t squared plus 6t to the minus 1, or plus c. Yeah, that's right. Problem 8. Let u equal y to the 4 minus 7y squared. Finding differentials, du equals 4y cubed minus 14y dy. Now, multiply both sides by negative a half we'll get negative a half of du, and that will be 7y minus 2y cubed, and all of that will be multiplied by dy. So the original integral becomes negative a half of e to the u du. The integral of e to the u is e to the u, so negative a half of e to the u plus c, and so negative a half of e to the y to the 4 takes 7y squared, all plus c. That's correct. Next, problem 9. D by dx of ln x is 1 over x. D by dx of ln of f of x is f prime of x over f of x. Now, I could do it that way, but I really do want to get almost muscle memory about this. So let u equal 4w squared at 6w take 1. Then getting differentials, we have 8w plus 6, all of that is dw. So a half of du equals 4w plus 3 dw. So the original integral becomes 1/2 du, which is a half u plus c, which is a half minus 1 plus c. That's correct. We will let u equal sine of 3t minus t cubed. Then taking differentials, du sine just like that. Then divide through by 3. So what becomes of the original integral? 1/3 over u to the 5 du. Add 1 to the power and divide by that. 1/18 of u to the 6 plus c, which is 1/18 of sine of 3t minus t cubed, all of that, plus c. Oh, beg your pardon, I forgot the 6. There we go. Got it. Problem 11. Let u equal e to the negative z plus ln of z. Then, computing differential, du negative e to the negative z plus 1 over z. So that's totally fine. So the integral becomes 4 out the front. That right there, excuse me, but there should be a dz. That right there, those two pieces right there become du. Like that, and make the replacements. Like that. Good. Problem 12. Evaluate the integral of sec squared of v times e to the 1 add tan v, all dv. d by dx of tan x is sec squared x. We see that. Let u equal 1 plus tan of v. Obtaining differentials, du sec squared of v dv, like that. So the original integral becomes, what does it become? E to the u du. Which is e to the u plus c, which is e to the 1 plus tan of v plus c. That's correct. Next, we have this integral here to evaluate. We will let u equal cos squared of 2x plus 5. And compute differentials, du. Now what's that? chain rule now. Then this 2 will come into the front, won't it? So you get a 4. That disappears. Dx. So to make that look like that, we will have to divide by -1 and multiply by 10. So times by, divide by -4 and times by 10. So times by -10/4, which is -5/2. Is it not? So now the original integral becomes -5/2 root u du. Compute. That's u to the half. So it becomes u to the 3/2. 2/3 of u to the 3/2. Which is 10/6. -10/6. Which is -5/3. Like that. That's correct. Now what do we have here? d by dx of cosec x is minus cosec x cot x. So that turns into that. There. Compute differentials. That there is replaced with du. That there is replaced with u. The integral of 1 over u is ln. That's correct. Arctan x is 1 over 1 plus x squared, isn't it? d by dx of arctan x is 1 over 1 plus x squared, right? It is, isn't it? That won't work. Wait. Is that right? Or am I misremembering? Yeah. So, yeah, so integral of that is arctan of x. So it will just be that, right? 1 plus that squared. Right? Right. That's 6. Just bring that out. Forget about that. It's exactly the same as that. Mm-hmm. Just let u equal y squared at 6. Right? Just do that. And du, then what am I doing? Not to is causing. Let me just think. Well, did you do this? Or did you consider this rather? Yeah. So you will get that. And Go on then, give me a hint. Okay. That's pretty good. I've got to think of that in the future. So what did I just say? Seven down there. Like that. And that is like, why don't I do this? One over root 7 y. That's what I think. And then let u just be 1 over root 7 y. And then we get u in that spot right there. Du, well, is that. Like that. So the integral now becomes 6 over 7. Root 7 on top, please. Integral 1 over 1 plus u squared du, like that. That is arctan of u, 6 root 7 over 7. Arctan of u plus c, and then 1 over y over root 7 6 root 7 over 7 arctan y over root 7 plus c. Oh no. Or is that an oh no? No, it's not an oh no because I rationalized the denominator, so that's fine. But I did get assistance for this one. You gotta admit, when you're stuck, you're stuck. And that's fine. Sixteenth. d by dx of arc sin x is 1 over root 1 minus x squared. All right. Just write that down. d by dx of arc sin x is 1 over root 1 minus x squared. Just there like that. And we are to play a similar move here, aren't we? Okay, you know what? I think this thing here is gonna become something like this. So first, I'm going to bring 4 outside of the brackets like that. Then I'm going to put a 1 there. And then they want me to do 9 over 4, but I'm not going to do that. Not ultimately, because now I see what to substitute. Because that thing there is 3 over 2, isn't it? I can see it. There. And now we pull that out. And so that is, you know, radicals there, 1 over 2. Okay. du equals 3 over 2 dw. Whoops. And what do you make of that? So that is 2 over 3 du equals dw. So now the original, please. I want a half on top. I want u there, and I want two-thirds times a half is 1/3. 1 over root 1 minus u squared du. And that is of arc sine of u plus c, which is 1/3 sine 3 over 2w plus c. Is it right though? Yeah. Okay, problem 17. Okay, du equals 18x dx. So 1/6 of du equals 3x dx. And the original integral becomes 1/6 1 over u du, and that is 1/6 of the natural logarithm of u plus c, which is 1/6 of the natural logarithm of 1 plus 9x squared plus c. And that's right. Do it this time. This should be fine. Hello dx. Hello dx. You're there. And now what does it become? It becomes 1/6 du over u to the 4, which is, that's u to the -4 plus 1 to the power and divide through by that. So u to the -3, but divide through by that -3, and it becomes -1/18 of u to the -3 plus c, which is -1/18, open brackets, 1 plus 9x squared, close brackets, to the -3 plus c. And check. And that's correct. And now, problem C. d by dx of arc sin x is 1 over 1 plus x squared. No, that's wrong. d by dx of arc sin x is 1 over root 1 minus x squared. d by dx of arc tan x is 1 over 1 plus x squared. Okay. But how does that help me? First, move the 3 outside. Then bring the 3 inside, like that. And let u equal 3x. Then du equals 3 dx. So 1/3 of du is equal to dx. And now the original integral becomes what? That 1/3 comes out, cancels out that 3, and so we get 1 over 1 plus u squared du. And that is arctan of u. Is it not? And that is arctan of 3x plus c. That's correct. Okay. Substitution rule for integrals. Save. Mean value theorem. Well, hello. What is the mean theorem? You have a function. You have a continuous differentiable function on an interval going from a to b like this, and it can go all over the place. Now think about the slope connecting these 2 points right here. There is somewhere on this curve that has that slope. Somewhere. At least one place. There, it seems. Possibly also there, and there, and there. You know, many places in this case, but there's at least one place. All right, why is this not loading? Oh, there it is. Okay. And what is Rolle's theorem? Special case. All right, I'll do it. For problems 1 and 2, determine all the numbers C which satisfy the conclusion of Rolle's theorem for the given function and interval. Okay, so first compute f of -1. That's 1, that's 2, so that's 3. 3 minus 8 minus 5. Compute f of 3. Square it, take the double of it, and take 8. That's minus 5. And therefore, there is a point from -1 to 3 which has the tangent line with a gradient of -5 according to Rolle's theorem. So we compute f prime of x, the first derivative, and we get 2x minus 2. And so we solve. 2x minus 2 equals minus 5. Add that -2 onto the others. I mean, add 2 to both sides. We get -3 over there. Divide by that. -3 over 2. But that's a problem, isn't it? Isn't it? Maybe it's because I've forgotten what it actually says. It says something very intuitive. If only I knew what it said. No, it doesn't say this. You're thinking of something completely different. That's actually totally bananas if you actually think about it. What it says is that the derivative somewhere between those 2 points is equal to 0. Remember? You remember. There. F of 1 is the square of 1. Take the double of 1. Take 8. So 1 take 2 is -1, and -1 minus 8 is -9. So the point in question that we're looking for is 1, -9. Right? Well, okay. C is equal to 1. I did something even more cool. I found the coordinates of it. But okay. Now do that for problem 2. Okay. First, just want to say that g of -2 is 2 by -2. Take that squared. Take that cubed. And what do we get? -4 minus 4, which is -8, plus 8, which is 0. And g of 1, so we do 2 times 1, take 1 squared, take 1 cubed. 2 minus 1 is 0, so vindicated and verified. Now, compute g prime of t. G prime of t is t. No, it's not. It's 2 minus 2t minus 3t squared. Then, well, in this case, it just so happens that these points also are on the axis. But that has nothing to do with the fact that I'm now going to solve for when it's equal to 0. So 2 minus 2t minus 3t squared equals 0. And is this factorable? Can it be factored? So b squared, well, that's 4. And then we have to add on 24, so 28. So you can't factor it in a pleasant way. QF. Do plus or minus. We just computed this, but we're going to do it again just to be sure. B squared is 4 minus 3 times 2. So that's 4 plus 24, which is 28. All of that is divided by -6. That right there is 2 root 7. So what do we get? We get First of all, minus 1 plus root 7 over 3. And secondly, root 7. I feel like I'm gonna actually mess these signs up if I don't be careful. Whoops, not right. Yeah, so that thing up there is fine. Then okay, times top and bottom by minus 1. So root 7 minus 1 all over 3. There. Feels so much nicer when it's like that. And are any of these in the interval? Root 7. How big is root 7? 2.6-ish. So that's 1.6 over 3. So the second one is both of them are. Both of them. Yeah. That's what I believe. What we're about to say. Yep. Okay, good. Problems 3 and 4 determine all the numbers C which satisfy the conclusion of the mean value theorem for the given function and interval. Very well. First, I'll compute h of 2. I haven't done it yet. Now, given my energy supplies, it would be better if I use the calculator. 4 times 2 cubed. Take 8 times 2 squared plus 7 times 2, and then take away 2. And we get 12. Four times 5 cubed minus 8 times 5 squared plus 7 times 5 minus 2, and we get 333. So that means, if I did it correctly, 2, 12 and 5, 333 are on h of z. Those points lie on h of z. Now, how can we say this? Let's just say gradient of secant. I think that's reasonable. 333 minus 12 over 5 minus 2, which is 107. That is the slope of the line connecting these 2 points. And the claim of the mean value theorem is that in between these 2 points, for this continuous and differentiable function, there exists a tangent line to the function that also has that gradient. At least one of them. There's at least one of them. And let's see how many there actually are. So we compute h prime of z, and we get 12z squared minus 16z plus 7. And we set that equal to that number right there. Divide through by 4. Can it be factored? Don't know. B squared is 16. 4ac, that's 75 times 4, which is 300. 316, so it can't. Okay, but that's fine. Don't expect them to be factorable. Plus or minus b squared, so that's 16 right, root 316, which is 279. Two plus or minus root 79 over 3. That, and we must confirm if they are actually in that interval. That one is. $3.629. My millennium eye. Yu-Gi-Oh. So that's not in the other one is not in the interval. So I'm going to declare that. So C is 3.629. That's what I say. Let's see if it's so. Let us see if what I say is so. Seesaw. It's correct. Problem 4. Same question. First, just is it differentiable and continuous? Yes. Compute a of -2, compute a of 3. Okay, 8 times -2 plus 387.4288. Good enough for me. Now 3. (2401) penitent tangent. That's your answer. And this shall surely slope down. Yes, it does. Good enough. Derivative, please. Derivative. A prime of t equals 8. That's true. Minus 3e to the minus 3t. So solve this. What's there? Take away 8. Divide that by -3. Compute the natural logarithm of it. Divide that by -3. And that's your answer. -1.097. So I believe that is the only value of C. And we check. Yes, I agree with you. Continuous on the closed interval, differentiable on the open interval. I completely agree. The habit of checking, the habit of checking. All right. Suppose we know that f of x is continuous and differentiable on the interval -7 to 0 inclusive, that f of -7 is -3, and f prime of x is less than or equal to 2. What is the largest possible value for f of 0? Okay. What do I do? What do I do? What do I do? Do 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 do. What do I do? What do I do? What do I do? Do 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 do. You think about Rolle's theorem, or do you? This is real understanding now, isn't it? And can my mind do it at this? Somehow. Let's just say that f prime of x is equal to 2, right? Then it's a straight line where m equals 2 and x1, y1 is -3, -7, and y minus y1 equals m times x minus x1. Plus 6, take 7, minus 1. There you go. And stick in 0. Well, hold on. There. Really? Yeah, I mean, it's just because of how I drew it. It is, isn't it? What is going on here? Quite. First, this calculation is wrong. It's y minus y1. X minus x1. What? How? Oh my goodness me. These are the wrong way around. That is just... Okay. Y minus y1, x minus x1, and (14) take 3 is 11, and so I will be incredibly surprised if 11 is not involved in some way. But that's me stumbling upon a solution instead of actually doing it properly, isn't it? First, I'm going to check if that's even relevant. Okay. And now I have to think. Mean value theorem. Mean value theorem. What do you say to me? Mean value theorem. Okay, how about this? This here is imposing a ceiling upon steepness. Now what I am doing is saying, let me suppose that I am always stuck to the ceiling, right? That's how I'm going to reach the maximum value of f of 0, and that's satisfactory to me. So, problem 6. Show that this cubic has exactly one real root. Just one, no others. Very well. First, I'm going to differentiate you. But that doesn't tell me anything just by itself. It just tells me that doesn't tell me anything. Why am I not getting it? Why am I not getting it? Double differentiate it. Just in case, just in case. Do you know why? Because I'm saying to myself, mean value theorem and Rolle's theorem must be the key to solving it. But what if they're not? And what if I want to solve it another way anyway? Can't be so bad, right? So, the first derivative tells me where the function is increasing and decreasing. And where it transitions from increasing to decreasing is going to be a max, a relative maximum. And where it transitions from decreasing to increasing will be a relative minimum. And if I can prove that both of these guys are above the horizontal axis, there is only one hole for that string to be threaded through. How about that? So, So solve this. QF time minus b plus or minus b squared minus 4ac 196. Oh wait, that has no answers to it, does it? You have no answers, and therefore it is if that has no roots, then that means that the entire function is increasing throughout. And that's all you need, right? (196) minus 12 times 25, and 12 times 25 is 300. And all I need to do is say that that is less than 0. So, no real roots. So this function, this cubic rather, I shall point that out. No, not just increasing, strictly increasing. And therefore, once it has passed through the horizontal axis, there is no way for it to ever come back down. Ever. But I don't know how to articulate that in a fancy way. Well, pretty much everything I said is totally irrelevant. And that's fine by me. Okay. Well, that's fantastic. Now, what else is waiting for me here? Optimization and more optimization and L'Hopital's rule and linear approximations and differentials and Newton's methods and business applications. Yeah, you don't scare me. Bring it on. Bring it on. Until I run out of energy. Find two positive numbers whose sum is 300 and whose product is a maximum. Okay. This is actually really cool to think about. I mean, I think it would just be the square root. But how to justify that? How to justify that? Okay. Oh no. No. That's total rubbish. No, it isn't. Yes, it is. It's 150. Whose product is maximum. Whose product is maximum. Okay, at the very least, if I can't think of the calculus that somehow justifies this, at least justify the answer that you have. So, first of all, the two, all the other possibilities would have to be some amount, A for amount, away from 150 and above it, below it and above it. And then when you expand this out, 22500. Sorry. What's this pattern called again? Difference of two squares, beg your pardon. That is a square number, and the only way to minimize that is to set A to be 0. Whoa, hold on, beg your pardon. That's very essential. So, to minimize this and thereby maximize the product, let A equal 0. Let's see what he says. Got the conclusion, but what's the reason? Oh my goodness me, what? Who does that? The answer has to be me. You have to understand what's actually happening here, yes? That I get. That I get. Set y equal to that. All right. Set it equal to that. Okay. There's like my function, which determines the product, the thing that I am trying to maximize. Now, I'm going to differentiate it and find the critical points. But why? The critical points are where the derivative is equal to 0 or is undefined. But why are you doing that? Well, because that helps me find the the absolute maximum is what I want, isn't it? And so I need to find where the derivative is equal to 0. That will give me the relative maxima, but then I need to establish that it's absolute. But anyway, that actually makes sense to me now. And you have to double differentiate to check that it actually is a maximum. And because it's negative, it must be a maximum. Gotcha. I understand now. All right. Find the two positive numbers whose product is 750 and for which the sum of one is 10 times the sum of one and 10 times the other is a minimum. Okay, so xy equals 750. Very well. I shall say, well, okay, don't use S. Just say sum. Okay, so y is equal to 750 over x. 7,500 over x. One. Oh, what are you doing? You're differentiating. Hello. Hello, hello, hello. That's x to the minus 1. Minus 7,500. X to the minus 2. And what is it that you want? You want that. You want to know critical points of that, don't you? Right? So, set it equal to 0. Or rather, set them equal to each other. So 1 over x squared equals 1 over 7,500. So x squared, x is equal to... X is the square root of that, is it not? What's that? 50 root 3. And what else? What else? What else? Okay. Problem. You don't know if it's maximum or minimum, do you? So, differentiate again. Double prime. $15,000 x to the minus 3. You plug them into there and you will see. Right. So, I believe is a... Wait. You nearly got me. Max. Now, let's just think about it logically. Okay, first, do these numbers actually even work? Okay, so don't just like assume. First, that's my value of what? X. So times that by 10. Okay, that's not right. So if I call that X and I call that, I have to be smaller than that. Yeah, at some point something got multiplied by 10 and I don't know where or why or how or who or what or when or whatever. Times everything by 10 somewhere. Right there. No, I didn't. y is equal to 750 over x. That's great, but wrong. Find the error. It's 10 times y. And what is y? Well, y is equal to 750 over x. And so all I'm doing is I'm just putting that in that spot right there. And then what? Then I'm doing that. And I can't believe it. Oh boy. Yeah, well. All right. All right, so midnight mathematics. I'm out of gas. Be well.